We have a MacBook Pro. It's 15 inches. The description says power on failure. Please diagnose and quote on options. And then the description here says dead. So I believe this is from the client, and then this was after the assessment was done. This is an A1990, and it says dead. Okay, so Peter did check this earlier, and then he said it seems it's a liquid damage device. Although that he didn't confirm, he was only saying that because of the texture of the keyboard. Okay, let's hope this is going to be one of the A1990 regular. That would be really great. So if it's the A1990 regular, so we hope it's going to be quick, and then we also hope that it's not it also has not affected the NAND, which is the onboard SSD. So let's quickly take our board, take the bar screws out to get to our board. Okay, the back screws are out. So yeah, this doesn't look like a liquid damage device. So um, let's see. Let's unplug the battery and see if we have a short on our PP bus. So I'm going to I'm going to leave the small meter permanently on continuity mode, and then we can use the big one for diode as well as a voltage measurement. So our black probe is going to go to ground, and then our red probe on our PP bus, the fuse is on our PP bus line. Okay, we do have a short on our PP bus line. Now, so one of the ways you can tell if the SSDs are affected is to look at this region here. This region here. So one of the ways you can tell if the SSDs are affected is to look at this region. So usually what will happen is if the SSDs were also affected, you will have a burnt mark here, which you can also see. You can also see that on this here. So I'm just going to open up the schematic to give you guys an idea. So let us go to, it's going to be this guy here. This is the board view. Let's see if we can open it on the other side as well. Okay, so now one of the ways you can kind of um, uh, you know easily tell if your SSDs were also affected is to see the color of U9080. So U9080 is going to be your voltage regulator. So what that is going to do, this is the chip that basically will take your 12 volt, which is a PP bus, and then turn that into basically break it down into a smaller voltage. So one of one of the ways this will fail, so the A1990 obviously fails in different ways. Now, if we go to the other side, so sometimes the common failure it's obviously is going to be C9080. However, sometimes when C9080 fails, now it depends on how it fails. So if at the point where when it fails, if the device stays longer, so if it fails and the device is still on, the chances of you getting your SSD destroyed and then the device goes off afterwards is very high. But if it fails and the device goes off immediately, then that is good, because that way a device doesn't stay on and then you do not get PP bus going onto your U9080. So usually what will happen, sometimes what happens is C9080 fails and then it also destroys C90 is you get it destroys U9080, and then you can actually see a burnt mark between C9 this between this and this. So So that's basically how you can easily tell. So in this region here, and we are hoping that this is going to be a regular C9080 failure, because it's a A1990 is one of the commonest failures that the A1990 have. But then again, we cannot confirm. We are just this is just based on the fact that this is a common expected failure on the A1990s. So that said, let's take our board, and we have confirmed that we have showed on our PP bus, and easily. So with the A1990s, you can easily measure at the two fuses here. Either of the fuses, they're on the same line, which is F7000 and F7001, and to see if you have, and please, when you're doing that, make sure the battery is disconnected. Now, with the battery cable is being disconnected, it's good enough. However, if this is a Chinese battery, oftentimes the calibration or the configuration might not work the same way as original battery. So what that will mean is even when you disconnect the cable, you may still have power going onto your board. So which would then say, if you can I mean, this you can confirm that this is indeed an Apple original battery. But if you cannot confirm that is the case, then it's best to remove the main battery power line as well. So you have the data, and then you have the main battery power line. So let's quickly take the board out. We are going to be using a T5. Did you give Usman anything to do? Okay, you sent him. Have you sent him to go collect? No, it's just wait now. Okay. Can you take my phone? I'll unlock it so that you can collect the package. You have to be quick before, because be quick so that you can doesn't have to stay for long. What are you waiting for? What are you waiting for? To do what? It has data. Yeah. So my friend is sending me a soldering iron. Is King Mark. It's actually one of the best in South Africa, I can tell you that. So if you happen to be in South Africa, you want to check out King Mark here. So he does repairs as well as sales. This is his website. He's yeah, I can tell you he's one of the best technicians in South Africa. And then the interesting thing is he's not just so not only is he a technician, the daughter also is a technician. So you have two technicians in the house. So and so oftentimes when he's not around, the daughter is in charge, and then she does amazing work. So they also have stock on Takealot. So if you want to get anything on technology, you can also check them out. So they sell parts, and they also sell complete units. And I can definitely vouch for King Mac. So if you want to do repairs, you want to do sales, if you want to buy parts for repairs. So talking about keyboard, trackpad, screens, even logic boards. I mean, if you want to buy any of those, so please do check them out. Let me see. Contact us. So yeah, you can do all of yeah. And let's see. Yeah, it's pretty much. Yeah, but if you are in South Africa, and then you are looking to do a repair, or you're looking to buy a part, please consider checking out King Mark. And yeah, I can really vouch for them. Okay, let's go back to our repair. So yeah, so the screws are out now. The next thing we want to do is to take our board out. Let us board is out. So the other time I spoke, okay, yeah. So let's the other time I spoke about how the C98, C9, the cap on the A1990, how it fails. So you guys can always check out my other videos to understand that. So this is our culprit. I'm just going to flip the board to the other side. So this guy here, C9080. So I did explain that. Now, C9080, if you see the description, it says PP bus underscore G3H underscore SSD O underscore SNS. Now, the short is not directly on your PP bus line. Now, that rail makes that line, it's bridged through R5620. So if we are to remove this, for example, then PP bus, it's going to be isolated from your NAND circuitry. Now this is the only reason why you have, if so, which what then happens is whatever short you have here, this is a current sensitive resistor, whatever short you have on this side is going to be represented here. Whatever you have here is going to be represented here. So the short that we're having is actually not on the PP bus itself. The short that we're having is being generated by C9080, C9081, which is this cap here. And this is, so basically when you flip the board to the other side, this is the cap, this one here. So this is not so bad. This is a cap here, this guy. And one of the ways, and then the way we obviously do that is just to do this, to just remove it from the circuitry. And there are more than, so that you, so before now what we would do is we would replace it, but now we no longer replace it, because what happens is when you replace it, it follows the same cycle. After a period of time, it fails again, and then sometimes the client may not be as lucky as the first time, which is the cap itself failing on its own. So if the cap fails on its own, then what would then happen is if you remove the cap, so when this cap fails, obviously you have the pin 1, which is sitting on the main line, and then you have ground. When the cap fails, you're supposed to have an insulation, you're supposed to have a material in between the capacitor. So one point is going to be on ground, the other point is going to be on your main line. Now, when it fails, there is no more insulation, so there's no more separation between. So which means whatever is on pin 2 becomes pin 1, whatever is on pin 1 becomes pin 2, which means that this line will be connected to ground. Now, when you remove this from the line, this line will no longer be connected to ground. Now, so you might wonder why aren't we replacing it? So I'm just going to open up the schematic to give you guys a clear idea why we are not replacing it. We used to replace it, but then we found that it's basically the cycle repeats itself. So it's C9081, correct? C9081. C9081. Okay, so this is our U9080. Here it says this on this page, it says SSD OPMIC voltage regulator VR. Now, see U9080, you see that C9081 is sitting on the line, which is the voltage in of your what? Of your U9080. Now on that line, you have not only C9080, you also have C98, C9073, C9074, C9080, and then C9081. Now, this is the guy that usually fails. Now you have four similar capacitors, which this failing and not being on the line, it's not going to basically affect the work of the other three. So it's pretty much okay. So we can remove this without having to replace it. So the reason why we choose not to replace it, because we have replaced it in the past, and then we saw that the same thing was happening, was because now the way this basically happens is this. Now, as your fans are working, your fans are basically obviously blowing, and then you get residues here, which is accumulation of dust, and then because of the board is facing this way, like this, and then also because of the fact that you have a high voltage line, which is a 12-volt line, so it tends to accumulate, it tends to basically attract, and then you get accumulation of dust there. Now and then you have a form of oxidation, just like as you guys saw, a form of oxidation, and that is going to be on more on the voltage side, because this is ground. So you will find it more on the on the voltage side, not on ground. Maybe on a different video, probably explain why that is the case. So if we install another cap here, the same process over time is going to happen again. So let's say for another year, or okay, not a year, let's say for another 2 to 3 years, the same thing is going to happen again. Now our warranty is 12 months. So yes, we know it's not going to fail within the time of 12 months, but then after 12 months, let's say in another 2 or 3 years, what's going to happen? So we then decided that it is actually better for the board that we do not replace the cap when it's taken out. So that said, and then also, how do you prevent it? I think if you constantly service your machine, by servicing you actually clean out the fans, and then clean out this section here to make sure that there's no dust, and then to make sure that there's proper free in and out of air into your machine. That will obviously really help. And yeah, so we have taken out the capacitor, but we have not actually confirmed if that solves our problem. So let us now see if our PP bus short is uh, still there or gone. So black probe is on ground, and then red probe, let's see. And that is beautiful. Our short, it's gone. So we see we no longer have a short on that line. So now we are just going to do the test, and then Peter is going to take it over from there. He's obviously going to do the finalization, but we just want to confirm that we now have a working machine. So of what he's going to do is to make sure that he does the service. What he's going to do is to make sure he cleans both sides of the board. But just for now, we just want to quickly test, because it's also time for prayers. We need to go to the mosque. So let's quickly test this, and let's hope that we now have a working board. And in a repair like this, you do not need any type of you don't need to use a soldering iron, or you don't need a soldering iron, or what is it called, um, or hot air to remove the cap. You can just use anything, like you guys saw. We didn't have to use any type of soldering iron or hot air to remove the cap, which ultimately means that almost anybody can do it. Once you can get your screwdrivers to get the board out, to get to the cap, then you just need to yank the cap out of the circuitry, and then you're good to go. And then this is only common on the A1990s. And then also another thing I also like to say is which is okay, maybe in a different video, where we also need to talk about how important it is to be sure of the state of your device before you plug power to it. Otherwise, you may just do more damage to a perfectly repairable machine because of the improper steps taken. So charger is connected. Do we have, yes, we have feedback on our trackpad. Expecting to see something on our screen. Hopefully the device is not in DFU mode or in recovery. Okay, that's good. So we just need to close the lid, Give it a bit of time. I mean, the fact that we have what is it called? The fact that we have the low battery sign, that tells us that our machine is actually now working. So this was a completely dead machine with a low power. And now, so after the cap is out of the circuitry, we now have a working machine. So I'm just going to give it a bit of a. Let's try it again. Let's see if it has enough juice to start now. Is the battery still down? Okay, the battery's down, but you guys get it. I mean, this is now working. So just give it. Just let's get a different and get a different cable. Okay, I have let's let's use the charger for my 16 inches. See if that's enough to override it. Okay, yeah. So that was a bit low, so we had to use a bigger charger. So as you guys can see, we have a working machine, and that's about it. Thank you guys. I will see you guys in the next one. The battery is on 0%. Yeah, so there's no need to actually put the device to desktop. Peter is going to take it from here. I hope you guys get the point, and then I hope you guys can benefit from this. Thank you guys. I'll see you guys in the next one.